mission, a scientific drilling ship that's currently in the Antarctic in the Ross Sea right now, looking at the history of Antarctica's climate to figure out what's going to happen to Antarctica in the future. So you can see behind me, we've got the drilling derrick, which drills hundreds of meters below the sea floor to collect sediment. That's the mud, sand and stones that are lying beneath the sea floor. Let's go and have a look at what the scientists can do with this sediment from the sea floor. Here we are going to the catwalk. So the catwalk is where the cores of sediment come once they've been drilled up from the bottom of the sea. They get laid out here and they're about 10 meters long. Then technicians will cut them into sections about 1.5 meters long, because that's about as much as you can carry. Then they get carried inside into the core lab. Come on in. Where's the one that's full? Here. So here's one of the cores, and it's 1.5 meter length. Now, it has lots of markers on it to show us exactly which core it is and where it's from, because as we go further down into the earth, the sediment is getting older. So we want to make sure we keep everything in order. And you can see inside this plastic case, there's just a lot of mud and sand and stones that the scientists really want to get into, because it can tell them all kinds of secrets about Antarctica's past. So the first thing that happens to those cores once they come in is they get put into this laser kitty, which does some laser engraving on the outside just to make extra certain that we're going to know which core is which. Then they get put in the racks to come to room temperature for a few hours. Then the scientists can start doing some measurements. Let's have a look at what they would do in the physical properties lab. So they do all kinds of measurements on the physical properties of the sediment from these cores. One thing they can do is they can shoot pressure waves or sound waves through the sediment, and that can tell them how densely packed the mud is, how close together all those grains of mud and sand are. They can also see the effect of radioactivity on the mud. They can also measure the magnetic susceptibility, which is basically how much magnetic material is inside the sediment. So if there's a lot of iron, for instance, we know iron's magnetic. If there's a lot of iron inside the core, then it will have a greater magnetic susceptibility. Okay, let's see what else they can do around the corner. In physical properties, they also measure the natural gamma radiation of the cores. Now this is how naturally radioactive the sediment is. Now don't worry, it's not so radioactive that it's going to turn you into Superman or give you cancer. It's just very slightly radioactive, same way that a banana is. But they pop the cores inside this machine, and then depending on how radioactive the cores are, can tell them some more details about where they're from, what kind of materials they're actually made out of. Okay. So let's keep going to the splitting room. So here in the splitting room, the cylinders get broken in two, just like a hot dog bun. So what this is just really a big blade that can split the cores into two halves. If the cores are really tough, if they've got a lot of stones in them, they can use these skill saws over here to cut them up as well. Okay, let's see what happens after they get cut up. here we are in the main core lab, where the cores come after they get cut up. So one half goes on this table here. This will be the working halves of the cores. So these halves the scientists can come, they can take little bits out of, they can mess around with and really get stuck into. The other halves go over here on the archive table. Now scientists are not allowed to mess these cores up because they want to stay nice and pristine. In fact, once the scientists have had a look at the archive halves, they get put over here in these special containers with a label on them, and then these will all get shipped to a big storage facility in Texas. The reason they do this is because that way, if they figure out some new way they can look at the cores, some new techniques, they'll have them for years to come in the future. So they can always come back to these halves and have a look at them later on, and they'll be totally beautiful and undisturbed. But the working halves are another matter. Let's have a look at some of the things that the scientists can do with the halves they are allowed to mess up. So here we are in the sedimentology area. So sedimentologists, they really just want to look at the cores, and they can figure out a lot from just looking at them. They might put some cores over here, and then they can look at the color. So they can actually tell a lot, even just from the color of the mud, if it's kind of brownish, if it's kind of greenish, and tell them about where it's come from, what's inside it. They sometimes see stones in the cores which have been dropped there from sea ice melting. They sometimes see shells, which usually only form when the ocean's quite shallow, so that shellfish can live in there. They sometimes see little burrows of worms that have been burrowing millions of years ago. They call that bioturbation. So as well as just looking at the cores, the scientists want to take really nice photos of them. So to take nice photos, they use the shill, which is just basically a really good camera, so they can put the core down here and just take lots of really high resolution photos. As well as using the shill, they can use this machine, the schmizzle, which will record basically the RGB values, so how red, how green, how blue each of the cores is. So it's a really good scientific measurement of color. Let's go around the corner here. Here are some sedimentologists hard at work, writing some reports. Over here, we take even more measurements of the properties of these cores. We can have a look at the amount of moisture in the cores by drying out little samples in a desiccating machine. You think this stuff is kind of like what's inside those little packets that you get in like chips and stuff that said do not eat. It's a desiccant that takes all the moisture out of stuff. So they can take all the moisture out of the mud and then take measurements of its moisture and density here. Okay. They can also do some more measurements of shooting pressure waves through the sediment, which can also measure its density. And they can also see how tough the mud is by trying to put these shears inside and kind of twist it around. Okay, so once they've taken all these measurements of the physical properties of the cores, then they want to look for any signs of life inside. So we'll go talk to the micropaleontologists who look at tiny fossils, which can tell us quite a lot about the conditions in the ocean when that mud was laying down. Oh, while we're going past, let's have a look from a distance at the magnetometer. Now the magnetometer can measure the magnetic field of the sediment. So it can basically measure if at the time the sediment was formed, was the magnetic field of the Earth pointing up towards the north or down towards the south. And we know the magnetic field of the Earth flips every so often. It actually is totally random when it flips. We still don't really understand exactly why it does it, but scientists here can use the fact that it flips to try and figure out the age of the cores that they're looking at. But we can't go too close to the magnetometer because it's a very sensitive instrument. So it's measuring very small magnetic fields, which can easily be messed up by electronic equipment. So we'll edge past it. Alright, and this area is where the micropaleontologists do their work, so that you can see them all looking at microscopes. What they're looking for are tiny fossils of phytoplankton and other little single-celled organisms that will have lived millions of years ago. By looking at these tiny fossils, they can figure out which species are there, and they know when about some time those species lived, and also what conditions they like to live in. So they might see a little fossil and think, oh, it would have lived about 10 million years ago, and it likes a kind of warm sea. So that means about 10 million years ago in Antarctica, the seas must have been a bit warmer than they are today. That's the kind of thing they can figure out. We have a scanning electron microscope on board the ship, which can take really, really fine resolution pictures, really small. As you can see here, Oscar's looking at things that are 100 micrometers across, which is on the order of human hair's kind of width across. This is where the paleontologists prepare their slides, and you also get a very nice view of the ocean from this room. Okay, let's go downstairs and look in the chemistry lab. Took off my hard hat. Alright, here we are about to enter the chemistry lab. Now this is where all the chemists do their work, understanding all the different elements and isotopes that are inside the mud that was collected from the seafloor. By knowing about all these different elements and things, they can figure out quite a lot about where the sediment came from, and also again about the environmental conditions. So there's all kinds of machines in this lab that measure all kinds of different chemical signatures from the mud. I'm going to show you a couple that I think are cool. Here's one. This is the squeezer. So what the chemists do with this is they put some of the sediment inside these presses, and then they put hundreds of thousands of newtons of pressure on it. They really, really squeeze it to get out a little syringe like this full of water. They can then measure the saltiness of that water and the pH, because then they can tell from the saltiness they can kind of tell stuff about how much sea ice there was around. The pH can also tell them a lot of valuable information. So they really squeeze their mud, and then they end up with just this kind of stuff left over, really kind of solid clay. It's really similar to the kind of clay you would use to make a pot with or something like that, but it's got most of the water squeezed out of it. Okay, so that's the labs, that's all the science that goes on board. Let's have a little look at what the scientists do after they've finished their science for fun. So here we are in the conference room. Now this is where scientists will come to just have a little sit, have a little go on their computers, but also where we've set up a ping pong table. So After a hard day of doing science, everyone loves to come in here and play a few games of ping pong. Hopefully later in the cruise we're going to have a tournament so we can see who's the champion player on board. Alright, let's go and have a look at the movie room in the gym. Okay, so here we are in the ship's gym. Now because there's not much of a chance to go for a walk or a run on the ship, it's pretty small, everyone makes use of this gym to make sure they stay in shape, and especially because the food's so good, we'll go up to the galley later, everyone's going to make sure they do a little bit of exercise in the gym. So we got some treadmills, we've got exercise machines, we got weights, you can plug in your own music and listen, so it's a really nice place to come after you finish work. Let's have a look next door, which is the movie room. Okay, we've got a nice lounge here with musical instruments. We've got heaps of books that people have left behind. I do wonder if they left them behind, is it because they're not so good books, but there's some classics in here, so I don't think that's true. Okay, so one of the best things in the ship is this baby, the ice cream machine. We got two flavors, vanilla and chocolate, and it's delicious. Okay, as well as ice cream, we have the second best, the Coke machine. And of course, if you combine the two, you can have what in New Zealand we would call a spider. I guess in the States you call it a Coke float, but ice cream and soda is the best. We have meals every 6 hours, so one at noon, one at 6 p.m, one at midnight, one at 6 a.m, because people are working on shifts. The ship is always working around the clock. The meals, there's always at least 3 options of things to eat, so it keeps everyone nice and happy. Also in between meals, we've got delicious baked goods that Albert the baker makes. Let's have a look at what Albert's made today. Oh, look what we got, some delicious chocolate chip muffins, some cinnamon scrolls, some cake, and looks like there's 1 donut left. So every day, twice a day, Albert does a round of baking so that you can come down and get a treat anytime. Alright, you can see here the lifeboats. So we have 4 lifeboats and they can each hold up to 70 people, which is about twice as many lifeboats as we need for the number of people, which is good because we don't want to have like the Titanic scene where like people are stuck and there's no lifeboats. That's not going to happen, so that's great. You can see there's some salt on the deck because it's about -1 degree Celsius out here, so it does get a bit icy sometimes. It's been snowing quite a lot. We're going to go head to the bridge now. Maybe we'll get to see the captain. We are on the bridge of the JOIDES Resolution. We're not actually moving anywhere right now. We just finished drilling at one of our sites. That's why there's no one steering the ship, because we're actually still. I really hope you enjoyed this tour, and I'll see you next time.